Imagine a perfectly normal afternoon. People are walking their dogs or enjoying a picnic, entirely unaware that 93 million miles away, the sun has just vanished from existence. We wouldn't know right away. It takes exactly 8 minutes and 20 seconds for the final rays to cross that massive gap. Down on the surface, we walk in the ghost light of a dead star, cocooned inside a shrinking bubble of radiation. And it isn't only light that's delayed. Albert Einstein's general theory of relativity tells us gravity is bound by this same cosmic speed limit. The gravitational pull holding our planet in its circular path is draining away at the exact same rate as the light. The final waves of energy and gravity race toward our atmosphere. On the ground, the clock ticks through the final seconds of the solar era. 7 minutes, 8 minutes, 8 minutes and 19 seconds. For these 8 minutes, the Earth continues to orbit an empty point in space, following a gravitational command issued by a sun that no longer exists. Then the sky turns black. Across the entire globe, the midday sun simply cuts out. Photosynthesis, the process that generates the oxygen we breathe and the energy for almost all plant life, halts immediately. If you look up, the moon has also vanished. It possesses no light of its own, acting only as a mirror for the sun. Once that source is gone, our closest celestial neighbor is erased from the sky. You might still see Jupiter for another hour. It takes that long for the sun's final rays to reach the gas giant, reflect off its clouds, and travel back to Earth. It is a final light echo before the outer solar system also goes dark. With that final echo gone, we are isolated. Humanity is physically and visually severed from the engine that powered our world for billions of years. At that same moment, the gravitational tether snaps. The invisible force that kept Earth in a stable loop around the sun has simply disappeared. Physics now dictates our path. Without the sun's mass, Earth abandons its curved orbit, traveling in a straight tangential line away from its former home. We rocket into the deep void at 67,000 miles per hour, crossing the outer planet's orbits in months. On the surface, panic is immediate. Solar power grids fail, the heat supply is cut off, and global surface temperatures rapidly decline. Our world has transitioned from a stable satellite to a rogue object. We are now a 60 sextillion-ton traveler, maintaining our velocity as we exit the heliosphere and enter interstellar space. Within a year, surface temperatures fall to -100 degrees Fahrenheit. This extreme cold freezes the world's oceans from the top down, turning the once-moving tides into a static shell of ice. This ice shell becomes a vital insulator. It traps the remaining heat from the Earth's interior, allowing a layer of liquid water to persist miles below the surface, warmed by our planet's molten core. Down on the ocean floor, geothermal vents continue to pump out heat. These vents become the final refuge for life, tiny clusters of extreme bacteria, and the last human survivors, huddled around the planet's internal engine. The surface is now a frozen planetary tomb, hiding a tiny, desperate pulse of life in the dark waters below. Millennia pass as Earth drifts in total darkness. At our current speed, it will take 43,000 years just to reach the proximity of Alpha Centauri, the nearest star system. The voyage is unpredictable. Without a home star's protective magnetic field, our planet is exposed to the hazards of deep space, collisions with rogue asteroids, or being pulled into the gravity of a black hole. There is a remote mathematical possibility that after billions of years, Earth could be captured by a new star, entering a new orbit and beginning a second solar era. The death of the sun initiates the Earth's longest transit, a multi-billion-year voyage into the absolute zero of the interstellar void.